Now this part looks like an absolute nightmare to machine, to program, to even design. But there's no problems with that because I'm here with Ben from SolidCAM who's done all of it. So first, how did you come up with the idea to do a leaf?
Well, that was part of the collaboration with Mazak. So Mazak tasked us with their eco and green strategy they're doing. But part of their new logo is a leaf. So they asked us to design some kind of trophy or element that we could show off their eco sort of friendly machining and everything now. So yeah, come up with the leaf, bent it out of shape in SolidCAM and then machined it.
So what was this like to actually design? Because obviously you said you bent it in SolidCAM, but you've got to draw this first.
Yeah, so I mean, we're using the power of SolidWorks, so SolidCAM plugs into SolidWorks, so drew the component flat first of all, got the correct shape of the leaf, and then using the surface modelling, I just bent it out of shape, flexed it just to make it look organic, and then yeah, we went from there.
I love how you talk about it because it just sounds like a 2-minute job. It sounds so simple.
Yeah. At the time it was a bit of head scratching, but yeah, it came together quite nicely design-wise.
Now, obviously, to program this, there's quite a few problems you've got to overcome, mainly because of the shape and also how thin it is. So, what sort of machining strategies did you use to get this? And I think for the people at home, the one in the machine has actually been machined today while we've been here. So there's no polishing, no nothing. And the finish is just incredible.
Yeah, no tricks at all. The one that's there has been machined in front of everybody. But yeah, the part's quite thin. So the strategies we've used, first of all, used iMachining on the front of it. So keeping the weight in the back, so keep the thickness of material in the back of this here. So machine all the front off first using iMachining, which is our high-speed roughing strategy. Then we finished all the front, did all the edge braking first as well. So we're using 5-axis automatic edge braking. Edge brake it all before we actually cut the shape while it's got the strength, and then when we turn over I've done the back in 4 slices, so we rough a slice, finish a slice, then rough another slice, finish that slice, just to keep that strength in it. So it's all about strategy, it's all about having that flexibility in the software to do that as well.
But what I love from what you were just saying then is you actually broke all the edges before you even machined it, because who likes filing? Let's be honest.
Who likes filing, yeah. And to try and break the edge once it's 2mm thick, you know, you're going to have a lot of ringing that's going to bounce, it's going to flex, so do the edge braking first. That's not something that people often think about, but it's a good strategy to use. You know, you break the edge off with a ball nose first of all. It looks a bit strange on the machine because all you're doing is digging into material, but it cuts nice, and then once you cut the pocket out and the shapes out, the edge brake's already there for you.
And I think exactly what you just said then. People think it looks strange because you're just ploughing into material, but then by the end of it, it completely makes sense.
Yeah, definitely, yeah.
There's something on the back I really want to point out is, obviously on the front, the pattern's just sort of indented a little bit.
Engraved on the front,
but on the back, that's actually protruding out.
Yeah, that was part of the design as well. So I was going to engrave the back. It's actually a mirrored of the front, so the front's engraved with the same shape. But on the back, I actually put those in and raised them up as a bit of a strengthener as well as part of the design of the part.
I like how you said a strengthener. To me, that just looks like more of a nightmare to program.
Yeah, it does. But using the strategies in SolidCAM, so again, that's 5-axis simultaneous on the back, just lacing across the part. So ball nose on the back, going up and down over all those little undulations. It's basically quite easy, and then you just tell it to tilt away when it's getting near the spindle. You'll see on some of the footage from today, the part gets quite close to spindle, spinning round. But again, it's all the power of simulation in SolidCAM. You can see that before you get to machine, before you have any issues. And the idea on the back as well, doing the ball nose on the back, the front's actually done with a barrel cutting. So the front of the component, it's got the same finish as the back, but the front of the component took about 1/5 of the time to machine with the barrel cutters. So again, showing off the power of new strategies. So, SolidCAM's quite capable of using all these new strategies, new tools from tooling companies, and yeah, showing that off really.
Yeah, like you said, it's all about learning them new strategies and taking them new strategies. It's going to help you.
Yeah, that's what we've got to be. We've got to be there. We've got to lead the way. All these tooling companies are bringing out new tools, new shapes of tools, new designs. SolidCAM needs to be able to use them, and we can. We've got quite a powerful toolkit inside SolidCAM. We can create any shape tool, and we can use those tools quite easily and quite freely as well.